All right, so let's look at the relations of the left lung. So most of the relations are usually perceived with the help of the impressions that are found on the medial surface of the lungs. So the first impression that we're going to be looking here is known as the cardiac impression. The cardiac impression is mostly done with the help of the anterolateral surface of the left ventricle of the heart. And then we have the infundibular surface, and then we have some parts of the right ventricle that also make up for the relations of the medial surface of the left lung. Now, it's important to know this because it's quite different from the right lung, because in the right lung we had the cardiac impression as the right ventricle, just the right ventricle. But here we have the right ventricle plus the anterolateral surface of the left ventricle as the cardiac impression. Then we can find that there is a relation with the left subclavian, the aortic arch, and the descending aorta posteriorly to the hilum. So there's a small region posteriorly that descends downwards, forming the aortic arch and the descending aorta, and then a smaller branch that comes off near the aortic arch, known as the left subclavian vein. Then we can also find the impressions of okay, what was that? Lastly, the impression of the esophagus, the right subclavian vein, and the thoracic duct. So more posteriorly, these are the relations. So let us summarize once again. First, the cardiac impression of the left ventricle and the right ventricle. And then we can find the other relation with respect to the great vessels, namely the left subclavian artery and the vein, and also the aortic arch and descending aorta. And lastly, we have the esophagus, the right subclavian vein, and the thoracic duct. Okay, so I'm going to show you how it goes about in the atlas right here. So that's the heart, and of course that's the lung that we're going to be seeing here. So we can see that there is this arch right here, the arch of the aorta, and then we have the thoracic duct that goes downwards. That is also one of the relations. Then we can find the infundibulum, the infundibular part, and then we have some parts of the right ventricle right here that are in close relations, and then most of the left ventricle that is in close relation to the medial surface. And then we can also find the auricle. This is the small auricle of the left atrium that's in close relation. Now, inferiorly, as you can observe, it's not really easy to observe, but this duct right here, sorry, I'm just gonna like pull this structure right to the middle of the screen. Oh, cool. Okay, wait, no. Oh God. Okay, just bear with me. Oh God, no. Come on. No. Oh God. Okay, all right. So yeah, that was the thoracic duct that I was about to show you. So it's not really visible here, but okay, so that's the thoracic duct. So the thoracic duct is one of the most important relation on the superior medial side of the right lung. Now, other thing that we can notice is the fact that inferiorly, of course, we have the diaphragm that's in close relation, but then diaphragm, of course, the diaphragm right here, that's in close relation. But then I also mentioned the esophagus being in close relation to this organ. So that's the esophagus, not really easier to see, but mostly the superomedial aspect of the right lung, the left lung. It's in relation with the medial surface of the left lung. So yeah, that's all. That's all that you gotta see. That's all. Now let's look at the supply of the lungs. So the lungs has a systemic supply. That means that the blood, the deoxygenated blood that is taken off from all of the parts of the body is supplied to the right ventricle through the right atrium. And from the right ventricle, it goes, all of the deoxygenated blood, it goes into the pulmonary trunk. Then there are branches of the pulmonary trunk, the left and the right pulmonary arteries that branch out, that enter the lung through the hilum of the lungs, and then they provide all of the deoxygenated blood that was gotten the from the right ventricle into the alveoli by the help of branching out. So it just branches out, the pulmonary trunk, it divides into two parts, and then it branches out, and then it takes in and supplies all of the deoxygenated blood into the alveoli. Now, what alveoli they do is that they take the oxygen. You know that when we breathe in, the oxygen is supplied into our body by the means of bronchioles and bronchi into the lungs, and these alveoli they help by exchanging the oxygen from the bronchioles in and making the deoxygenated blood oxygenated. So that's the oxygenated blood, which is then put into the pulmonary veins, and these pulmonary veins, they go into the left atrium, and through the left atrium the blood goes into the left ventricle, and then it is supplied to the entire body by the means of aorta. Now let us take a closer look onto the pulmonary trunk. So the pulmonary trunk divides into the left pulmonary artery and the right pulmonary artery, as we know. And these two arteries, they follow the bifurcation of the two bronchioles. Now we know the primary bronchi divides into segmental bronchi, and then segmental bronchi divide into lobar bronchi, and etc., etc. So that's how it goes in the case of pulmonary arteries too. They divide into segmental arteries, and they divide into lobar arteries, etc., and then it just goes and it supplies the entire alveoli. Now, once the job of the alveoli, that is to make the deoxygenated blood oxygenated, is done, the alveoli goes and it forms the blood it needs to go somewhere. Of course, it needs to be supplied to the body now. Now the blood that is oxygenated there's a need to supply this oxygenated blood inside the body. And how this happens is by the means of veins. So the pulmonary veins take the oxygenated blood. So that's the pulmonary veins that take it, and they eventually dump the entire oxygenated blood into the heart by the means of of course, the left ventricle. Now, from the left ventricle, it goes into the aorta and supplies the oxygenated blood everywhere. But that was the systemic supply. That means that it was actually just for the body. We are more concerned about the body. But what about the lungs? Where do they get their own supply from? They do get some blood supply, some oxygen from the veins, the pulmonary arteries, and the pulmonary veins. But the actual oxygenated supply of blood is done to the lungs by the lungs through the bronchial arteries. So we have the right bronchial arteries and the left bronchial arteries. Now, it's important to know that both of these arteries are not really the same length and have different origins. So we know the fact that we'll see later in the atlas that there is quite a close connection of the left lung with the artery. So we can say that the left bronchiole, there's no need for any bifurcation here. So for example, I'm just going to draw it right here in order to make it more clear. So this is the aorta, and this is the aorta, and then this is going to be the lung, the left lung, and this is the right lung, and here we have the vertebra. So as you can see, there is much more smaller distance. This distance is much more smaller as compared to this distance, and hence the coming off of the left bronchial artery is just from the thoracic aorta. But for here, there is the formation of something known as the intercostal artery. And from the intercostal artery, we have one branch that is known as the right bronchial arteries that supply the right lung. Okay, look, so this is gonna be so I'm gonna show you how is there the bifurcation of the pulmonary artery. So this is the pulmonary artery, the pulmonary trunk, sorry, not the pulmonary artery, the pulmonary trunk that divides into the left pulmonary artery and the right pulmonary artery. Then it's easier to see it from the posterior aspect. You can see that coming off of the left ventricle, the left atrium, we have the insertion of, don't be actually, don't really be misunderstood by the way this is portrayed as an artery. An artery is supposed to be something that supplies blood. So the supply of the blood is going to go in this direction from the lungs into the left atrium of the heart, and this is going to fill the heart with oxygenated blood that's going to be supplied onto to the body with the help of the aortic arch right here. Similarly, we have the similar structures on the left side too. Then let us look at the other structure known as bronchial arteries. So it's not really visible here, but the small tuft of arteries that you see here coming up directly from the aorta. So as you can see that this is the one. These are the bronchial arteries and the veins that come off of the aorta and supply the left lung. There's a direct coming off, there's a direct supply from the aorta itself. Then we have another artery that comes off of the intercostal. I know it's not really visible here, but this is the intercostal vein, intercostal artery. And coming off of the intercostal artery, we have this the bronchial artery that supplies the right lung. So we can see that there's not a direct supply from the thoracic aorta. Rather, it's a direct supply from the intercostal artery that comes off of the thoracic aorta. All right, now let us see the microstructure of the alveoli that are the basic functional unit of the lungs. So we studied about the trachea, and then when we saw about the microstructure of the trachea, we noticed that there were certain types of cells. So these cells include, so this entire part is a trachea, and the cells that are included in the trachea include the ciliated, the goblet, the basal cells, the ceramicus cells, neuroendocrine cells, and the brush cells. So these are present just in this portion. But then as we go downwards, as we go into the primary bronchi, so this is the primary bronchi, the number of cells, the amount of cells, it goes on decreasing, and certain types of cells are absent at incompletion. So basically we have the cuboidal cells, okay, they are there. We don't have the goblet cells here. We don't have, we have the basal cells, okay, so we have the basal cells, we have the ceramicus cells, we don't have the neuroendocrine cells. So here in this portion, we don't have goblet cells, and we don't have neuroendocrine cells. Then let us go to the other part. The other part is, let's compare these two parts. That's the, maybe this is the lobar bronchi, and this is the segmental bronchi. Or maybe it's the reverse. Okay, whatever. So just compare this part, just compare this part with this part. You can see that we are deleting the ceramicus glands here. So we just have three types of cells now: ciliated, clara, and brush cells in this direction, in this part. Now let us go on to the last part here. This is the bronchiole. So at the level of the bronchiole, we can find that there is no presence of brush cells, but instead that these cells are replaced by type 1 pneumocytes. And then we have lastly the alveoli, where 90% of the alveoli are filled with two types of cells, type 1 pneumocytes and type 2 pneumocytes. So we are now inside the alveoli. So that's the alveoli. I know that it's quite different in this image because normally the alveoli looks something like this. But in this image, we are taking a small cross section of this alveoli and seeing it from the inner side. So the first thing that we can notice, the first thing to know is the fact that there are about 300 to 400 million alveoli in each lung. And all of these alveoli are responsible for the exchange of gases, and hence it is important that the walls of the alveoli are thin. So it's quite thin. The wall of the interalveolar septum, or the wall of alveoli that connects one alveoli to the other, is very thin, measuring approximately 0.05 micrometers. So that being said, there's only a small barrier of 0.2 millimeter between, not micro, sorry, millimeter between two alveoli that facilitate the diffusion of oxygen-rich air from one alveoli to the other. Now, there are also different types of cells that we're going to be seeing here, namely the type 1 pneumocytes, the type 2 pneumocytes, and the alveolar macrophages. Type 1 pneumocytes are the primary cells that do not really differentiate, and they are less numerous as compared to the type 2 pneumocytes, because type 2 pneumocytes are much more bigger and they take up about 10% of the alveolar surface, but they're not really they're more numerous as compared to type 1. And type 2, what they do is that they differentiate and they can form type 1 pneumocyte. They can replace type 1 pneumocytes due to the fact that type 1 pneumocyte don't really actually differentiate after a certain amount of time. For example, after birth, they don't really differentiate to form more, so they're replaced by type 2. Now, other thing that we can notice is the fact that there are some small spaces known as spaces of Kohn or interalveolar spaces or pores of Kohn. Now, alveolar spaces of Kohn are just two spaces that facilitate the movement of air between two adjacent alveoli, and they are most closely associated with so that's a type 2 pneumocyte, type 2 pneumocytes. Then lastly, we have the alveolar macrophages. Of course, a macrophage is something that's a phagocyte and is used for it takes care of the debris, and mostly it gives off an immune response and is like it takes action against bacteria. So keep that in mind, yeah.